Hello, everybody, and welcome to Intro to Coding, as well as Coding for Games. I forgot to press start at the beginning of my live tutorial, so here is me re-recording the start of the tutorial for today, for those of you watching the recording on YouTube. So, Intro to Coding and Coding for Games. So there's a few things you're going to need for this tutorial, and those are posted in the chat during the tutorial. However, if you're on the slideshow, you can get them from the slideshow. And that's just in our GDG resource drive. So you'll need Unity, you'll also need Visual Studio Code, and our unfinished side scroller Unity project. So what that's going to be is that's a game that's half completed, and there's a bit of a missing script in the game that we're going to be rewriting. So what is on today's agenda? So we're going to take you through a few things today. So first thing is why code. So it's kind of a bit of an intro to what is coding, where does it come in games, and what is its purpose? I think that's just a good kind of overview to get you started on kind of what is the reason I am doing this. Then we'll get onto some coding basics. So that'll just be, there's no experience required for that. That'll be just teaching you coding from the ground up and coding your game. So at that point, we will be heading into Unity and getting some scripts for our game. And the last hour or so will just be me available to answer a few questions, but otherwise it's you guys just having a go at finishing up the script on your own. So why code? Coding makes the game world go round, essentially. So what it does is it's anything that happens in a game gets to happen because of code. So if a bullet gets fired, there has to be some code telling the bullet to move and go ahead. When the bullet hits a player, there needs to be some code to say, okay, this player needs to take some damage now. When the player's health gets too low, there needs to be some health saying, okay, this player dies now. So the code is just what pushes the game forward and gets it to run, essentially. We talked earlier about art in our previous tutorial, and what that covers is, that really covers the communication aspect of our game and how that kind of allows our message, allows our game to deliver a purpose. But coding is what creates the game and is the backbone of what lets it do what it wants to do. So there are a few things that happen when you are coding, and this is kind of just how code works and how it gets games to do stuff. So the only part you really need to worry about is scripting. So scripting is where you write up your instructions for the computer in a programming language. And I'll let you know in a bit how to figure out what programming language to use. So after you've written the code, what will happen is your computer will take a read of your code and it will do something called compile it. So your computer, all computers actually only understand machine code, essentially. And all of that just kind of looks like a bunch of squiggles and numbers and things, and it's not very readable. So that's why we don't code in that. We code in something easier to read, which is a programming language. But what compilation does is it reads what you've done in your programming language, and it translates it down to something the computer can understand. And then you'll just have a version of your code that the computer can understand. And then we have runtime. So at runtime, your computer takes the translated code that it can understand, runs it, and basically follows the instructions that you created in your program. And at that point, you are a programmer. So where do I start? So one thing that's kind of tricky with programming, I don't know if you guys experience this, but I definitely experienced this a lot in my first year of university. Even now to this day, I experience it. But to write code, you need to choose a programming language to write in, and there are loads and loads and loads of languages. So it's kind of like, what one do we choose? So it's important to know, first of all, that different people will have different opinions on this, but in my personal opinion, there aren't any good or bad programming languages. There are just programming languages that are good for different types of projects. So it's up to you really to look at your project and be like, okay, what do I think will be the most suitable language to write this in? So for example, a programming language like R is really, really good for data analysis and statistics. A programming language like Scratch is very, very visual and is really good for teaching people how to code, and especially for kids, teaching them those coding concepts. Python has loads and loads of libraries that are community created. So it makes it really popular for machine learning, because it's really hard to build up a machine learning base all on your own. So what you can do is you can kind of go and download machine learning libraries that already exist, so you can build off of those. And something like Swift, for example, is Apple's app development language. So if you want to make an app for iOS, you have to use Swift. Those are just a few examples. Okay, I'm recording now. Oh my goodness. This is better, it's better than nothing. We have most of it. Thank you, Justin.
Yeah, at least we caught it now.
Welcome to programming, everybody. Okay. Clinton is not going to be happy at me. But okay, so the language we are choosing today is C#. And I really like C#. I'm a bit of a C# fanboy. And the main reason for this is because Unity uses C# as scripting language. So it wouldn't really make much sense for me to teach you something else and then be like, okay, now learn this different one that we're going to use in Unity. It's also got I personally think it's got a pretty low learning curve compared to similar languages. And one of my favorite parts about it is that it runs on something called the .NET framework. And all you need to know about that is that's something Microsoft has made to make sure it is cross-compatible across all sorts of platforms. So you can get your games on mobile devices, you can get it on all sorts of different types of computers, Mac, Linux, Windows. It's just really good for being very versatile. It's also object-oriented, but you don't need to worry about that now, but that's going to be really useful for, you're going to start seeing why that's useful when we get to the Unity part. Cool. So the basics of coding. Are you guys ready? So here is a quick exercise for you guys. We have a robot and there is a white road in front of him and there is a flag he's trying to get to. And the robot can't do anything without being told by someone to do something. So what would you guys tell him to do to reach the flag? Any thoughts? Oh. Go up till the intersection, then go right. Yep. Yeah, so once you've told him that, he knows how to do it. Awesome, thanks, Justin. So yeah, it might look something like this. So walk up, you get to an intersection, stop walking, then move right. Programming's not really that much to be scared of, because that's all it is really. It's just telling a robot to do things that you want it to do. So the difference is that when we do programming, we need to write it in a really specific way that our computer will know how to understand. So that is called a programming language. And again, as I mentioned earlier, we'll be using C#. So a language is just a specific way of writing out these instructions. Cool, so how that might look as code. I'm aware this is a big jump from the last set of instructions, but we can break it down and we can see that it's the exact same thing. So our first instruction was walk up. So we have this if statement here. So that means the exact same thing as if in real life. So we're just saying, if our robot is not at the intersection yet, and the exclamation mark is just code slang for not. You put an exclamation mark instead of writing the word not every single time because we're lazy. So if we're not at the intersection yet, then we're going to change the y value of our position to the same value plus 1. And if you guys remember from high school maths, hopefully, we have in a graph, we have a y-axis and we have an x-axis. So the y-axis is going to be our up and down, and our x-axis is going to be our left and right. So what we're doing here is we're basically just saying, if you're not at an intersection yet, keep adding 1 to your y value. So he's going to keep going up. So these curly braces are just basically saying, run all of these bits under this if block. So once we start being at the intersection, we can start changing our x position by 1 instead. So our robot will start moving right. So what these semicolons mean as well, I was a bit confused by them at the, when I first started coding, but they're just the code version of a full stop. When you're done with your line of code, you just end it with a little semicolon, and that's basically just telling your, it's basically what my bullet points were here. So it's just telling your code, okay, we're done now. You don't need to do anything else until the next instruction. So that is basically how we write code. We want our computer to do something. We figure out how to write that in the computer language, and we're done. Run it. Cool. So, it also, guys, if I'm going too fast or too slow, feel free to let me know. But cool. So, types and variables. So one question you guys might have is, okay, it's cool that there are these things called position and at intersection and stuff like that, but how does the computer know what those are? Because I kind of sound like I'm contradicting myself. I'm kind of like, oh, you know, the computer needs to be told things. They don't just know what something means. And then I'm putting in these words. So what these are called is variables. And variables are just a box that holds some kind of a value. So basically at intersection is going to hold a true or a false. It's going to be true if our robot's at an intersection and false if it's not at an intersection yet. So that's that at intersection box here. So inside this box, there would be a true or a false. Position is probably going to be a number. So it's going to be maybe if he's at like an x value of 5, position will be 5, for example. And that's how you can do maths with those numbers. So the reason why we have variables is because first of all, it's much nicer to read code that looks like this, that you feel like you can kind of read as a person, I can read this and it kind of reads out like if not at intersection. I'm like, okay, cool. That makes sense to me if I'm reading it. So it's one thing that's really nice about it is it helps us actually read code easier. It's also because they're called variables because they can change, but we might want to have a value that changes around but still has the same name. Like, for example, my age is a variable. Like, it's still my age, but it's going to continue to increase as I get older. But I still want to call it my age. So that's why we have variables. So these variables have different types. And you might be like, why do we need to give them types? This just makes things more complicated. And I agree with that. But the best way I can think about it is that it's like if one of your variables was a string and you tried to do maths on it, that shouldn't be possible, right? You shouldn't be able to do cat plus dog. You should only be able to do maths on numbers like 1 plus 2, 0 plus 8, and things like that. So these types basically just tell our computer, this is the kind of thing you can do on these variables. And it works the same for these things as well. So in integers and floats, floats is just a fancy way of saying decimal numbers like 3.15, and int is just a whole number. The reason those are separated out is that in computer storage, the computer needs a little bit more room to store a number with a decimal in it than it does for a whole number. So it needs to know how much space to kind of partition out. Hopefully that makes sense. So there are certain things you can't put in certain types of boxes. So for example, if one of your variables is an integer, you won't be able to put a word inside it. The way I like to think of it is different shaped containers. It's kind of like, okay, you can have a water bottle, you can have an egg carton. You can only really put egg-shaped things in an egg carton, and you can only really put liquids in a water bottle. If you tried to put a liquid in an egg carton, it just wouldn't fit. So these are like different shape boxes for different shape things. Cool. So I spoiled the first question a little bit. I would like you guys to have a little think. Looking back at this piece of code that I wrote earlier, what type do you guys think the variable at intersection is, and what type do you guys think the variable position is? Full float, full point. Cajun, what did you mean by point? Full vector 3. Awesome. Jeff's going a little advanced there. Because you are technically right, Jeff. But we'll get into that later. So yeah, the variable at intersection would be a bool because it can only be true or false. It can't have a value of like yes or it can't have a string value like yes or a integer value like 8 or 9. And the positions x and y are going to be integers or floats. They're going to be a type of number, basically. It depends how you want to program the game. Jeff is technically correct, especially in terms of Unity, that position is a vector 3, but we will get into that later. It's basically because in real life, position has an x, y, and z value, so it can move around in a 3D plane. Cool. So let's do some scripting. Help solidify that learning. So if you guys could head over to .netfiddle.net to code along. It sounds kind of confusing, but if you see what's on the screen, it should make more sense. Hassal, if you could post the link there in the chat as well, so it's a little easier to get to.
No worries.
Be awesome. In the meantime, Jeff, I thought you guys were in the breakout room. Did something happen? Or...
Oh, we finished.
Oh, cool, you guys are done. Sweet.
Yep.
Nice.
Good timing because I am at the end of this section as well, so I'm about to get back into coding with Unity. But you guys can probably join along for this exercise as well. Fiddle. Net. That wrong. Fiddle. There we go. Cool. So has everyone managed to get onto that okay? Awesome. So what I would like us to do today is I want us to write a basic script just to get a bit comfortable with how coding and how types and things work. So you guys are welcome to just watch the screen, but if you guys have .NET Fiddle up on your side as well, you're welcome to code along there too. So what we're going to be trying to create today, and I'll say this exercise out loud now, so those of you who are already familiar with coding can have a go with it. We want to create a really, really simple command line script that asks the user to input 2 numbers, and then what our code will do for them is add those numbers together and tell them their answer. So you guys are welcome to try and make a start on that if you like, but if not, I will start writing the script and I will be explaining what I'm doing as I go. Cool, and as always, feel free to let me know if you guys have any questions. But what we have here is, you guys can see the script that they automatically give us is the script called Hello World, and it's like I feel like it's like the standard script. I think it was like the first script it was the first programming script to ever be run, the Hello World script. So most languages have that as like a default now. But you can see with this code that they've given us here, if I press run, it prints out Hello World down here. Now, you guys don't need to worry about all this stuff out here for now. All you need to know is what we're going to be writing is going to take place in here. Cool. So we have this thing called console, and that's what you think it is. It is connecting to the console down here. And console.writeLine means we are going to write a line out of the console. So C# is pretty intuitive in this way. So for example, if we wanted to change this to GDG is best, we could run that, and you can, I don't know if my font's too small. Can you guys see that from your screen?
A little bit small, I would say.
A little small. All right, I'll see if I can just size my. There we go. Is that a little better?
Much better.
Awesome. Cool. So you can see when I do console.writeLine, it is printing out this line that I am giving it. So basically what we want to do is we probably want to write to the user, what is your first number? Because we're going to try and get the user to get 2 numbers, and then we're going to get 2 numbers from the user, and then we're going to add them together. So our first line is, what is your first number? So if we run this, our computer now asks us for a number. But now we need to be able to type it in. I'm like pressing numbers here and nothing's happening. And it's because we haven't actually told the computer, okay, now take in this number. So there's actually a line called console.readLine, which does which is kind of opposite side of the coin to console.writeLine. So that's basically going to read the line for us and take it in. So we can see there's a problem here. It's not liking this. And the main problem is we haven't actually given this line that we're reading. And so readLine is just going to take in whatever we input. We haven't actually done anything with this. This isn't going anywhere, is it? So where do we put things? How do we store things when we're coding? It begins with a V. I mentioned them earlier. Variable. Awesome. So we're going to create a variable. What should we call it? What do you guys think is a kind of good name to call a variable like this? That's just someone's number. Don't call it bar.
Yeah, just call it like if.
Poor advice. Well, I'm going to call it, you can call it very cool numbers, also a good idea. And we'll also call it something like first number, because we're also going to be expecting a second number at some point. We're going to say first number equals console.readLine. Still got a bit of a problem. It does not exist in the current context. And what that means is we haven't given it a type yet. And like I said, computers don't know what to do with things if you don't tell them what kind of thing it's going to be. The computer's just sitting here like, is this going to be a string? Is this going to be a number? Am I going to get a float? I'm confused. I don't know what to do. So we need to tell it what we're going to give it. So let's just give it an integer. Let's just make it an integer for now. We're just going to add whole numbers. Cool. So now this is an integer. One last error. We cannot implicitly convert type string to int. So when we do console.readLine, because you can put anything into your console, it's going to think it's a string. So we need to convert that to a integer. And how we can do that is something called pass, which is just the fancy code way of saying, okay, change my type to something else, please. So I'm going to use int 16 dot, and that just means that you don't need to worry about the 16. It just means an integer basically. So int 16 dot pass. And what do we want to pass? We want to pass what we're getting from the, what we want to pass what we're getting from the user. Cool. That was a lot of information very quickly, but hopefully, I'm not expecting you guys to understand every single thing I'm doing here. As long as you guys are kind of following along with the logic I'm doing in terms of my programming, I think we'll be just fine. Cool, so let's give this a run. So now you can see we can actually input stuff. And that's because it's still waiting for our read line here. So that's that second instruction we've given it. So let's put in 10. And that's the end of our program. And that's because that's all we've written. So for our second number, my favorite part of programming, copying and pasting, we're just going to turn this into second. We run this now. What is your first number? 10. What is your second number? 11. So now we're inputting two numbers. So the last step we need to do is add our numbers together and print it out. So that the user knows what their sum is. We're basically making a very terrible calculator. Cool. So now we're going to create a variable, as always, called sum. Because we could just do first number plus second number. But if we do that, then because we didn't make a container for the sum, there's nowhere for this to go. So we need to do sum equals first number plus second number. Why do you guys think there might be an error here?
You didn't initialize the variable basically.
Yeah, yes, we haven't given the variable a type yet. So sum will be an integer as well because we're adding two integers together. Guys, cool. So now we have int sum. Do you guys think there's anything else we need to write to finish off this code, or do you think this should be it?
Well, I mean, you probably want to put in something that shows the result.
Yeah. Because so what I'll show you guys what happens now. I keep pressing save because like I have this like instinct to hit save anytime I do anything. I forget that I'm in my browser. So we put in our first number is 10 and our second number is 11. We can see we don't get a sum, and that's because we haven't written an instruction to say, okay, show the user now. So if we want to write something to the user, we just want to do our classic. No worries, thank you, Darren. Cool, so we're going to go back to our classic console.writeLine, and we're just going to say your sum is, and then what you do in WriteLine is you can just string lots of things together. So if you want to, so what you can do is you can keep adding things together. And so that's how you connect up different pieces of information. So for example, so I'll show you guys what that looks like. So you guys can see that these strings are all being printed out. But what we don't want to say the sum and blah, blah. We want to tell the user what their sum is. And all we need to do to finish off this code here is just write sum. Cool. So let's say our first number is 3, our second number is 5, your sum is 8. And that is our first program. I'm aware that this is a lot of information to be starting with, but hopefully it kind of makes sense. Programming is mostly learning how to understand the logic that goes on behind writing these things. And then once you do that, you can transfer that between kind of any language you're writing in, most languages you're writing in. Cool. Does anyone have any questions on that part? Otherwise, if not, I will move on to Unity. Cool. Let's hop back into our slide. Pretty similar to Python. Yeah, it's I can't remember, is Python object-oriented?
Yes, definitely.
Yeah, just Python
Yes.
doesn't have any like strict typing stuff. And
No.
No, it is the most flexible of the bunch.
Yeah, yeah, I had my suspicions it was object-oriented, but it definitely doesn't feel as object-oriented as some other languages.
It wasn't like that originally. Yeah.
Yeah. But yeah, it's why I like it is because it is a little similar to Python in terms of its readability. I feel like what I really like about Python is it's really close to English. So I read it, and if you've written your code well, you can basically read it out like a sentence. And I do a lot of coding when I'm tired, and the last thing I want to do is try and figure out what code is trying to say. So coding your game. So hopefully at this point, you guys have downloaded Visual Studio Code and Unity, as well as that game. Let us know if you haven't, and Tassal will flip those links through for you guys again.
Yep, I'll do it again, just in case.
Awesome, thank you so much. Cool. So what we need to do is there's a little bit more setup we need to do just to make coding with Unity quite nice for you when you're programming. Cool. So you'll need to install these two things, one called the .NET Core SDK and one called the .NET Developer Pack. The Sal will send those through in the chat as well. There's nothing you guys have to do in terms of these except download them. But as I don't know if you guys remember earlier, but I said that C# was part of something called the .NET framework. And that framework is what's running behind the hood, like under the hood with C#. And that's what's taking our C# and making it work on Windows, on Linux, on mobile. So the .NET SDK will kind of grab your C# and get it running. And the .NET Developer Pack, I just get you to download because it has something called IntelliSense for VS Code, and that means it will auto-complete some of the things you're typing, some of the Unity things you're typing, and I really like that because who wants to write their own code? So get those downloading, and I will move on to the next slide. Cool. If you guys were at the last art tutorial, this should be familiar to you, but you will also want to open up the unfinished side scroller demo game. So this is the game that we're going to be using today. So once you download it, right-click the zip file and select extract all. Once it's finished, you can see I copied and pasted this from the last slide because I didn't change the game name. That should say unfinished side scroller. Click on the extracted file and navigate to assets and then scenes, and then double click on sample scene.unity. And that will open up your game. And you can hit the play button on the top of the editor to have a test of the game. Let me know if you run into any issues with playing the game. Cool. This was also a note I wanted to add. You don't have to use VS Code. So if you're a programmer who's already very comfortable with a different IDE, you don't have to use it. If you go into, once you've got your project open, if you go into Edit, Preference, External Tools, then External Script Editor, highlighted here, you can select whichever editor you'd like to use. I personally really like Visual Studio Code, but you can choose whatever you like. Visual Studio is also supported for this. It seems confusing because Visual Studio and Visual Studio Code are two different things, and I definitely say the wrong ones a lot. They really should have thought that through more on their part in terms of the naming department. If you're really crazy, you can change your editor to Notepad and just write plain text if you like, but it's nice to have an IDE. Cool. So an intro to Unity editor. Are we downloading .NET SDK or the runtime environment? You will be downloading the .NET SDK, and then for the second link, I'd like you to download the developer pack. Actually, you know what? I will show you guys. I don't know. I was planning on doing a demo, and I think I forgot. So I will show you. Cool. So when you open up this link here, we'll want to download the SDK. And then at the second link, you'll want to come down here, the developer pack, and just download this .NET Framework developer pack here. That makes sense. Cool, cool, cool. So, an intro to Unity Editor, and I'll talk you through this, and then I'll show you guys what you should have on your screens when you've opened up Outgame for today. But you will have a toolbar up the top, and up the top, that's kind of where you keep all the things that help you move around as a developer. So that's like if you want to rotate something, or if you want to move an object around on the screen, or you want to just move through your game and rotate your camera in the world, those are going to be your best friends. That'll just help you look at the game better and get to where you want to go. We've got the hierarchy window over here. So these are basically, in short, just all the things you have in your game, and all the things you have in your current scene. You have your game view and your scene view. This is why I really like Unity. So your scene view gives you kind of like the God bird's eye view of your game. You can move around it however you like. And as you do that, your game view will show you what a player will see. So you can actually put those side by side if you like, and view as a player what's going on in the world. You've got your inspector window. So when you click on something, the inspector is going to give you all your information about that. And F is your project window, and that's basically a glorified file explorer that's built into Unity. Cool. I'll take this opportunity to go a little more in depth about what some of these things are. So I'm not sure if I've mentioned it yet, but I think I mentioned it just before. These are objects, these things in the hierarchy. There are these things Unity calls game objects. And it sounds a bit vague, and it's because it is. Game objects are vague, so you can add your own things to them and make it specific. Anything that you can think of in a game that's like a thing is probably a game object. So like an enemy moving around is going to be a game object. A weapon's a game object. Text is a game object. And so the inspector shows all the components of the game object you currently have selected. So say I have my enemy in the hierarchy here. I'll click on my enemy, and my inspector will show me all my information about that enemy. So the next question might be, okay, so you've got game objects, then components. What's a component now? So a component are properties of a game object. So for example, I've written here, an enemy game object will have a few components. They will probably have a sprite component because they'll want to have a model or something so you can see it's an enemy. They will have a collider. That's what they're called in Unity, but you might know it more colloquially as a hitbox, as well as they will have some scripts that you've written for the enemy. Those are all components. The way I like to think about it is game objects are kind of like just an empty kind of body, and then components are like behaviors and personalities and stuff that make up a person, or make up the thing. Because you like when you're thinking about a human, like what makes you you is your personality, the way you behave, you know, what you look like. Components are where you define all of that stuff. The game object is just stating that there is a thing. It's like this empty shell. And last but not least, the project window contains all your resources for your game. So those are called assets in Unity. And it's essentially a file explorer. So you can go through and have a look. If you create scripts, sprites, animations for your game, those are all going to be saved here. And what you can do is you can drag them out onto your scene. So the difference, a question I sometimes get is, okay, what's the difference between the project window and the hierarchy? Because those are all kind of objects. Your assets is kind of like your toolbox. And when you pull them out into your scene, it's like taking your tools out and putting them on the table and bringing it out into the world. So your assets are just sitting there waiting to be used. And in the hierarchy, they're telling you the ones that are being used. Cool. Hopefully that makes sense. Does anyone have any questions at this point? Cool. Very fast learning. So I'm not sure if anyone's gotten the game open yet, but if you've had a go at playing the game, which you can do by going to your toolbar and pressing the play button, you might notice the player does not move. Nothing happens. You can press WASD, you can press the up and down button, you can press side to side. It doesn't do anything. And that's what we're going to be scripting today. We're going to script our player to be able to move, similarly to how we were telling our robot to be able to move before. So if you guys can keep your games open, let's script. I will also do that. Cool. Can you guys see that?
Yes.
So just to show you what I mean, I'll hit play. And you can see our player's here. He drops to the ground. And I'm pressing all my keys. And he's not doing anything. So we are going to tell our player how to do things. Was that a question? What was about to be asked? Or you guys all good? All right. So we can see we've got our hierarchy here, just like there was in the slideshow. So I have a few different objects in my hierarchy. I've got my instructions. Those are just this text here. I have an event system. We don't need to worry about that. That's something Unity generates, and it takes care of stuff itself. Sorry, do we have to open the extracted file from the project tab? Cool. So what you guys, so you should extract the file, and then when you open up the file and go into it, there should be files like this. You should go into assets, scenes, and there will be a file called samplescene.unity. So if you double click on that, you should it should open up your game for you. No worries. Oh, I forgot to mention earlier. I was supposed to do this as a lot of areas as a part of the VS Code setup. But what I'd like you guys to do as well is, where I put this as a slide. Did I skip over it? I would like you guys to open up your script here. So let's code the player movement script. So if you go into the scripts folder in your file explorer, and then a player movement script, we have this empty script here. Are we using a rigid body instead of a player controller? Yes, we are. I'm a bit of a purist. I like doing everything from the ground up by myself. I'm sure a player controller would be easier, and I should probably take a look into it. But I have more fun when I'm doing everything from the ground up myself. Cool. So at this point, you guys should have your VS Code open. And what I'm going to get you guys to do first is go to extensions on the side here and search up C#. And this is going to be crucial to getting C# working on your IDE. So I already have it installed. You should click on this first one here. That's by Microsoft. And it's got its little like Twitter verified stamp next to it. And you will want to install that. Cool. So once you've installed that, what you should have is you should be able to code, and you can see that Unity will fill in some suggestions for you. So you can see if I type game, it'll suggest, oh, do you mean game object? And I'm like, why, yes, thank you. I do mean game object. So that's why we downloaded the development kit. It does useful things like that for us. Cool. So that was just the setup for VS Code. Sorry for jumping around everywhere, but I think what I'll do first is I will go over a little more about Unity, because I have thrown you guys into the deeper things a bit with Unity, and it does seem a bit scary. The first time you open it up, I was a bit overwhelmed for sure. So you can see that we've also got a level, and you can see when you click on these game objects, it highlights what that game object is. And we've also got player. It highlights our player here. I'm glad you're excited to go over rigid bodies, Jeff, because I'm about to show you guys the player's components. So as Jeff mentioned, this player has a few of these components. I've given it a rigid body and a box collider. So as I mentioned earlier, colliders are what you guys might know as hitboxes. So I'm giving my character a hitbox so it can get hit. I'm also giving it a rigid body, and that's Unity's fancy way of, that's my way of telling Unity, use gravity on this thing. Give it like a weight, make it kind of like exist in space. Because you can, something I wouldn't want to give a rigid body is something like, for example, the text. I don't want the text, the instruction text here, to be affected by gravity. I don't want it to like fall all over the place, but I do want the player to fall all over the place in the nicest way possible. So the player has a rigid body, and Unity will apply physics to it. And that's what I really like about Unity, and that's why so many people recommend it over making your own game engine. Because you can imagine if you're making your own game engine, things like physics and stuff, all of that you'll have to program from the ground up. You'll have to write a way to apply physics to everything in your world. You'll have to write a event system. With Unity, I just chuck a rigid body on it and be like, okay, do your physics thing. And Unity is like, all right, cool. So that's what these components are. Hopefully that makes sense, and I haven't just spewed information at you guys. So I have been able to drop down this player. So this player owns a few things. So our player has a sprite. Obviously, our sprite is just a fancy word for our picture that we want to give it. So our player has an image connected to it. It's also got a jump collider. That's left over from, you guys can ignore that actually, we can probably delete it. That was left over from me trying to make the jumping nicer for this character. And we also have a main camera. Now the camera is really important in Unity, because the camera is basically what the player is going to see. It is what our user will view. And you can actually see down here, main camera. You can see if I move this around, you can see the main camera changes where it is. And so it's like if we press play, like the camera is rendering this screen here. Cool. So why why is it under player then? Does anyone have any ideas why I might have put it under player rather than outside like this? So when I say under, and that's what we mean by this idea of hierarchy, game objects can own other game objects. So what I'm saying is basically, because the main camera is under the player owns the main object. The player is a parent of the camera. Is it to track the player? It is to track the player. Congratulations, that is the correct answer. So you can write a script to make your camera follow the player, and you can give the script, here's an object I want you to follow, and things like that. But the problem is that I'm really, really lazy, and I don't want to do that. So instead of writing a script for that, I can just say, okay, camera, you are now owned by the player. And that means wherever the player goes, the camera goes now. So that's a really easy way to make the camera follow the player, and you don't have to do any extra scripting. So if you're making a 2D side scroller, that's your first tip of the day. If you want the camera to follow the player, just make it a child of the player. So from now on, instead of referring to things as owning, I'm going to refer to things as children and parents. So I hope that makes sense when I say the player is a parent of the camera and the camera is the child of the player. And the last object we have here is just the level. And this is just a bunch of ground objects. And there's a box here. And we can also see there is a win over here. And there is a damaging zone here. So one thing I really like about being able to make things parents and children is you can just categorize things. So it makes my level really neat. I can just see, okay, this is the ground of my level. This is the box in my level. This is how you win my level. And this is how you get damaged in my level. If you want, you can open everything up and see all the disgusting stuff that's in here. In a later tutorial, if there's interest, we can make this more efficient by using something called a tile map, which will save you from having to copy and paste lots of things over and over again. But for now, having all of these will do. Cool. So, any questions as of yet? I will get you guys started with writing the script, and I'll teach you a few things about how to script specifically for Unity. But otherwise, the last hour or so, I'll give you guys a start, and I'd like you to problem solve, see if you can problem solve your way through the rest of the script itself. Cool. So, anytime you make a script in Unity, and you can do that by right-clicking in your scripts folder, pressing create, and pressing C# script, it will create a default script that looks like this. It will give you a void start and a void update. So you can avoid, you can ignore these voids for now. They're not, I'll understand later. A void is basically a type, which just means nothing. How do you open the unfinished side scroll section in VSC? Cool. So if you go, can you see your well, it's called, I always just call it the file explorer. Can you see your project console down here with all your files? If you double click into scripts and just double click on the player movement script, it should automatically open. Let me know if it doesn't, because then there are ways around that. What's it currently doing, Angela? Got open editor. What I'll do is I'll finish up this tutorial, and we'll pop into a breakout room afterwards, and I can help you out, unless it's a common problem amongst a lot of people, in which case I can fix it. Yeah. Oh. Does that work for you? Awesome.
I could go into a breakout room to help. If that's necessary.
Awesome. Would you like to hop into a breakout room with Clinton and you guys can see if you can fix it? Or should we do that after the tutorial?
How close are you to finishing tutorial?
Pretty close. I'd say another 10 minutes or so.
Yeah, why not?
Yep, cool. Awesome. So I'll just go over what all these things mean, because this looks a little bit different to the .NET Fiddle we were looking at before. So mono behavior is something that all of these things are Unity things basically, and that's why it looks different, because it's just a Unity thing, not a C#, not like a base C# thing. So mono behavior is something that Unity's created, which just basically says this object exists in a Unity world, use Unity rules on it, and then when it compiles and stuff, it handles all of that. But as I said earlier in the presentation, we only have to worry about scripting. We don't have to worry about compilation. So we can ignore that. So we have these two different functions, start and update. These are also Unity functions. So start is going to run at the start of our game, and update is going to run every frame the game happens. So I think that is, depending on what you've got your game set to, that should be like 30 frames per second. So this update will run really, really frequently, 30 times a second. So any code we want to have run at the start of the game, like initialization code, is going to go here. And any code we want to run over and over again, any checks we want to keep making, is going to happen in update. And what I will also refer you guys to is because these are not the only functions there are in Unity. They have loads of them. One I can think of off the top of my head is on collision. I cannot spell today. On collision enter. And this is another Unity one. And what it does is when it detects a collision with an object, it will run this code, which is really useful for things like bullets. It's like, oh, if I've detected a collision with a bullet, then I'm going to run this code, maybe like deal damage to the character, something like that. If you search up Unity documentation, you should be able to peruse through that, and that will give you all the different functions that are available to you to use. But start and update are the two big ones. So what we want our character to do is we want our character to be able to move. Currently, he doesn't do anything. So I have already created a script called input handler. So that's going to take our inputs and turn them into something useful. So what I want you guys to do first is use my script. So if you type input handler, input, I'll call it my input. And what we're doing here is we are creating a variable, just like we did in JS Fiddle, except this variable is of the type that I made by myself. And that's of type input handler. So we are creating a variable because we want to have an input handler. We will create it. So what we'll do from here is at the very start of the game, we want my input handler to be game object. Game object just means this object that the script is running on. So for this script, game object is going to be player, because as you can see, our player movement script is on our player. So if I can find my code again, my input handler is going to be game object dot get component, because we want to get a component from the game object. And we want to get an input handler. And because this is a function, we want to do brackets. Oh, I forgot to go over functions in my first tutorial. Basically, functions are, if you have code that's going to run lots of times, you don't want to copy yourself. You don't want to write code over and over again. So we put them into functions that of reusable code. So getComponent is a function that Unity has written for us. Cool. So what this line is telling our computer to do is saying, okay, I want my input handler to go into my player, get the component from it that's called input handler. So what our code is going to do is it's going to run, it's going to open up player, it's going to be like, all right, I'm trying to find an input handler. I'll get this one here. And then I will make it mine. So this is what this is referring to now. So what my input handler code does is it's going to track what the user's pressing. So it's tracking if they're pressing the A or D buttons or the right and left buttons. And because this is a very brief code overview, it's hard to teach code in 1 hour. The main thing I recommend for you guys, honestly, is going through and practice. But I'm hoping that this will give you somewhere to start off of. But I'm happy to go over the input handler if there's interest later. But the main thing you need to know about it is that it has a variable called movement input, and that's what we're interested in. So the movement input is just detecting whether or not the player is pressing the movement buttons or not. So the first one we can see it's saved like this. So the first part of it is horizontal and the second part of it is vertical. I'll start writing and hopefully it'll start making sense. So for example, if we want the variable that we would access, if we want to check if the player is moving horizontally, is my input handler dot movement input dot x. That will check if the character is moving left or right. So that's the name of that variable. What button would we, what do you guys think the variable name would be if we wanted for the character moving up and down? Not. It would be y instead of x. So y will check if the character is moving up and down. X is checking if the character is moving left or right. So just like in my presentation, Unity has something built in called position. H and V, that's a very good question. As you can see in here, it's saved as H and V, right? So wouldn't you want to call it by H? But you can see H doesn't represent anything here. So this is a default way that Unity handles things like this. So because we've saved it as a vector2, which is a type that is just a fancy way of saying, okay, this is 2 numbers, not just 1 number. It always by default saves the first one as X and the second one as Y. So it's really easy to get. So it doesn't matter, I could make this like, I can make this one like beans and this one apple. And I could change that here. You'd still access it by X and Y. So X just means the first one and Y just means the second one. Cool. So Unity has something handy. It actually handles position for you. So if you want to get to the player's position, you have to use something called transform.position. And transform.position is your character's, basically just your object, where your object is. So I'm going to create a variable, position, character position equals transform position. And what that's going to do is that's going to save the position in this variable. And so what we want to do is if we want the character to move left and right, we need to add, just like in the PowerPoint, we need to add some numbers to its position if it's moving left and minus some if it's moving right. I think it's the other way around actually, if I'm remembering high school maths correctly. So you might be wondering why I'm just writing var here instead of vector2 or something like that. It's because Unity is very nice, and C# is very nice, and it can magically figure out what type you want it to be. So it's quite smart like that. So if you give it something, it'll check what type this is, and it will automatically make your variable that type. So I just use var for everything. It renders my whole conversation about types a little bit useless, but I think it's good to understand anyway, because those types are still there. Var is just a fancy way C# guesses it for you. Cool. So now we have a character position, and that's just going to be the same thing as where our character is. And the main reason we do that, instead of just saying transform.position equals transform.position plus 1, the reason we don't do that is we can't just add stuff like that. And things get a little bit confusing. So it's just a lot nicer if you create your own variable and you can add stuff to it yourself. So character position, just like in our PowerPoint, I want to go if, so character position dot x equals character position dot x plus, let's say, 1. And let's leave it like that for now, and we'll see what happens. Press play. So nothing happens. And that's because we haven't set our player's transform back to this variable we've created yet. So we'll go transform.position equals character position. So basically we're just saying, what's good about this format is you can make all of your changes to character position here. You might want to be doing, when your game gets more complicated, there might be a lot of logic you're going through there. And then right at the end, we say, okay, we're done with our work. Now make our character's position this. Cool, so let's see how this goes. So we press play now. Let's see what happens. So our character goes flying through the world. And even though I'm not pressing anything, so why is that happening? That's because I haven't used I haven't used our input anywhere in here, and we want this to be to do with our input. We only want the character to move if our input is going in there. So what I'll do is I'll do that variable we got from before, my input handler dot movement input dot x times, let's say, 10. That might be too much. Say 1. In terms of these numbers and stuff like that, you kind of have to guess them and keep testing them until you get a speed that you like moving with the character. So let's give this a go now. And I promise this is it for today. I've been talking your guys' ears off for the last hour. But let's give this a go now. So we can see that our character doesn't move anymore. But if we press left and right, he moves around very, very quickly. And that is an indicator that your number is too high. This is why we have testers. So I'm going to go change this number to something more reasonable, like 0.2. In Unity, you need to put an F after your float, just to tell it it's a float. Cool. Let's have a play of that now. Didn't press the play button, that's why it's not playing. See, our character moves around. And he's gotten stuck inside an object. You guys are curious about that. I have to tell you about it, but I'm also aware that we're going over a lot today, so we can cover that later. But hopefully that's made sense you guys. I know I've dropped a lot of information on you guys at once, especially those of you who are going from knowing nothing about coding to jumping straight into it. So kudos to you guys. But basically what I've done here is I have gotten my character to be able to move. And it's only really taken 4 lines of code and 1 line that just creates a variable. So basically gotten an input handler, we've asked the input handler to check if the player is pressing the left or right button. And then we're getting our character's position. We're going to add 0.2 to it if we're detecting an input from the character, from the player, and then we're going to set the position back to that change number that we made. That's what those 3 lines do. Hope that makes sense. So my challenge to you guys is that some of you may be more hardened veterans in terms of coding, and if anyone's used Unity before, you may have already finished implementing the movement feature. But my challenge to you guys is to see if you guys can figure out a way to make the character jump. Because as we can see here, we're only messing with character position.x, right? We've still got character position.y. So right now our character doesn't move up or down at all. So if you guys can have a go at seeing if you can get the character to move up and down somehow, I think that would be really good. One thing that will be useful for you guys is that there is gravity acting on the player. So what you'll want to do is there is a function called add force that you should search up and have a look at and see how it works. And that might help you getting the character to jump. Cool. So I know that might have been confusing and it's not the most comprehensive coding lesson, but I would like to end this presentation off by just saying, open up my thanks slide while I do this. I would like to end this presentation off by saying the main thing when it comes to coding is practicing and Googling. If you can't figure out how to do something, there is a 99.99% chance someone else has had the same problem before. So if you Google your problem or what you're trying to get your character to do, you can search it up. So what's really good, what is really good for that is Unity forums as well as Stack Overflow. Those are 2 websites, and I can link those to you guys later. Though there's lots of questions about coding there. What's also really good is the Unity documentation. So you can also search up Unity documentation, and it's basically a big user's manual to using all the things that are in Unity. What is really lucky about Unity, and what we don't get with a lot of tools and languages, is a lot of them have really, really bad documentation. So even though they have it, you read it and you still can't figure out what you're supposed to be doing with it. But Unity's documentation is done really comprehensively and really well. I am also happy to send through a few beginner Unity tutorials on YouTube. The main way I learned how to develop games was just continuing to go through lots of YouTube tutorials and following through those over and over again until I kind of knew what I was doing. Unity has a really big community, so there are loads of there's loads of YouTube content on how to create games in Unity. So what I can say really is tutorials, Googling, practice. That's your holy trinity. Are there any questions at this point?
No, I think what you've said is pretty sound. And I just suppose that as time goes on, as we're able to do more projects and follow more tutorials, I think we'll get a better grasp of this. And then that's when it'll get really exciting because yeah, it's just like I guess the beginner step of getting the basics, and then as soon as you have that, you can really start exploring different ideas.
Absolutely. Yeah, that's a really great point. And I think that's why instead of a focus on tutorials in Game Dev Guild, we have a focus on our GDG jams because
Yeah.
I think it's hard, but you learn way, way quicker if you get thrown into the deep end in terms of developing a game and just getting straight into it.
Yeah, no, that'll be so good. Do you know
yeah.
when the first one is?
The first round will start in 2 weeks. So we will have one more tutorial next week, and that will be purely on Unity Editor. So you should be able to take your coding knowledge from today and perhaps your art knowledge from the previous week, and we'll go a little bit more in depth with, okay, what's the Unity Editor all about? What can you do with it? What are some more features it has to kind of help connect your games up? So we'll go a little bit more in depth about the hierarchy as well as what a lot of the components do.
Nice.
Cool. But yeah, but I guess what yeah, but after that we will begin our GDG rounds, GDG jam rounds, and genuinely, I mean, I'm kind of like I feel like I'm kind of proof that they work a little bit at least, because I mentioned this last tutorial, but this time last year I was sitting here watching Clinton give these tutorials with no knowledge about Unity whatsoever, and I just kept joining the GDG jams, and now I know a little bit more about what I'm doing.
Awesome. Yeah, definitely looking forward to it. It's gonna be
Awesome.
really cool.
Practice makes perfect.
Absolutely.
Yeah.
I kind of hate it sometimes because sometimes I'm too lazy to practice, but it is the hard, honest truth.
Just about discipline though, right?
Yeah, it's about drive, it's about power.
Right.
Yeah.
All right. Perhaps you'd like to tell us like what the next tutorial is about?
Yeah. So the next tutorial will be about Unity Editor. I'll bring up my screen again, but it's a bit more in detail dive, and because I kind of glazed over them today, I was just kind of like, okay, this is the parent, this is the child, these are the game objects. But what I'll do in the next tutorial, and it will go really well hand in hand with the coding tutorial, because I think there's a lot that's missing from the coding tutorial there's a lot that's missing from coding in Unity without knowing much about the Unity editor. So what I will go into next time is I will teach you guys about all the different components we have, how you can give your objects components like the rigid body and the box collider, what they do. And if we get really exciting, I will show you guys, and my game over here, I'll show you guys particle effects, which I really like just because they look cool, but it's basically, Unity has a built-in way to make sparkly things happen, and I just like sparkly things. So if we get far enough tomorrow, I'll show you guys how to, not tomorrow, next week. We'll look at some of Unity's inbuilt tools like that. So if that sounds interesting to you, then I'd be glad to see you guys there.
All right, so that brings an end to our tutorial. We've got a few notices. First of all is the membership fees. Izzy, do you happen to have the bank account details somewhere?
I don't have them on me right now, unfortunately, but I can find them. And I'll stop sharing. Also, just to anyone who is having trouble with their code or needs help, we'll be around till 8 o'clock. We'll be happy to help you out.
All right, so yeah. All right, well, you find the membership bank account details. So the membership fee is for the club members, like we need it to support the club and get events running and stuff, as well as like guest speakers, catering, and all sorts of good stuff. So we'd really appreciate it if you could pay the low price of $5 per semester.
It keeps us running and keeps us delivering fun events to you guys.
Mm-hmm. So just leave your phone name and I think reference, or was it particulars? And then your social medias tag in the other one, so we know on Discord or Facebook, like your social media tag.
Okay. Oops, I've just sent that as a private message. Sorry about that, Jackson. Here we go. Here's the bank account number. The other place you can find it is in our, at the end of our sign up form. It's a recent change we made. So if you signed up a while ago, you wouldn't have seen it. That's a fix we made recently.
So
Awesome.
yeah, put phone name as reference and main social media handle in particulars. Also, I remember Izzy mentioning this in launch night, but I will reiterate here. If you want to apply for executive positions, say you want to help out to see what events are out there, or maybe connect with industry, or maybe you know some engine other than Unity and you want to like teach that, that would be cool. So I'll fetch the exec application form and post it in the Zoom chat. Just give me a second.